So how many of you guys are training machine learning models today? Raise your hands. How many of you guys are training those models on remote infrastructure like AWS EC2 instances? So that's a little bit less people. There are still significant barriers today to training models on remote infrastructure like in a cluster. And that's what I want to talk about. I want to talk about machine learning infrastructure and how it aims to reduce operational barriers to model training. And what I want you to walk away with is I want you to walk away with a better understanding of how to build or how to evaluate machine learning infrastructure tools today. So as Denise said, I'm Alexandra. I work at SIGOPT. We build an API for hyperparameter optimization. Hyperparameter optimization helps you find good performance for your models by helping you search the space of hyperparameters. Hyperparameter optimization involves training your model more than once. You have to train your model on sometimes dozens of different configurations of hyperparameters in your search for the best configuration. So roughly, hyperparameter optimization allows you to trade off available computational power for better model performance. Now, imagine, and this won't be a stretch for many of you, that you are tasked with building a machine learning model and maximizing the performance. You may want to use a technique like hyperparameter optimization to maximize the performance of your machine learning model. Now, imagine your machine learning model has 10 hyperparameters. You may need to train 100 configurations of your model to find the best set of hyperparameters if you have 10 hyperparameters. Training 100 configurations of your model, let's say that takes 6 days. That's a long time to sit around while your model is running a hyperparameter optimization experiment. So you might want to start training your model on a remote infrastructure, like a cluster. This is a common problem that happens with many data science teams today. So data scientist wants to use hyperparameter optimization. You want to train your model in a cluster because you can parallelize that hyperparameter optimization evaluation. You can train 6 models at a time, and instead of training for 6 days, you can train your model for 1 day and get the results of your experiment. Training a model in a cluster allows you to access to more computational power than your local laptop and allows you to complete your optimization experiment a lot faster through the use of parallelization. But whose responsibility is it to get the model from your local laptop to the cluster? You're a data scientist and you're tasked with building the best model possible, but getting the model from your local laptop onto something like an AWS EC2 instance sounds a little bit more like a job for the DevOps or the infrastructure team. And here we've got 2 competing sets of specializations. Machine learning experts specialize in gathering data, extracting insights, building models, and DevOps teams are usually the ones who manage clusters and build shared tools. So as a data scientist, what's your option? Do you make a round trip to your DevOps team every time you want to launch a hyperparameter optimization experiment? Or you could just have everyone on your team become this magical unicorn who not only specializes in building incredible machine learning models, but who also specializes in being incredible DevOps engineers. And that doesn't sound like a very realistic or easy to hire for proposition today. Machine learning infrastructure was designed to solve some of the problems, bridging the gap between machine learning and infrastructure. Now, this is not something that I came up with. It's been around for a while. And like many other terms in machine learning, it doesn't go by just one name. Sometimes it's called MLOps. There's a lot of different terms for it. And there's a lot of different definitions out there. Broadly, I would define machine learning infrastructure as solving model building workflow problems with infrastructure and DevOps tools. So machine learning infrastructure might be able to help a data scientist launch a model in a cluster. Unfortunately, just saying those magic words doesn't do anything, though. You actually have to, can't just know what machine learning infrastructure is. You have to actually have a machine learning infrastructure tool. So what I want to do for the rest of my talk is to give concrete examples of machine learning infrastructure in action. I told you before that I want you to walk away from this talk with a better understanding of how to build and evaluate machine learning infrastructure tools for your team. So at SIGOPT, we do hyperparameter optimization. We've been working on a machine learning infrastructure project for the last year that aims to help people launch hyperparameter optimization experiments in clusters. So the 3 examples of machine learning infrastructure that I'm going to show you came from our project called SIGOPT Orchestrate. I want to show you real-world examples of the data science workflow problem, how it translated into a technical challenge, and I want to show you the tools that we used to solve the problem. But in all honesty, I don't want to show you only the leading-edge machine learning infrastructure solution. I also want to show you the tools that we selected to build this machine learning infrastructure project in context of our new tool, and I also want to show you what we used in context of our old tool. So for every workflow challenge, I'm going to show you 2 different iterations of solving it. I'd recommend that you use the second one that I show you, but I do think it's important to show that these machine learning infrastructure tools aren't just magically popping up out of the ground. They had a slightly messier basis to them. Going back to this example, you're a data scientist, you want to use hyperparameter optimization, you want to train 6 models at a time, and your laptop doesn't have the bandwidth to do this. So you now need to train your models in a cluster so that you can train 6 of them at a time. The technical challenge is you need to set up all these remote instances to be able to run your code. Our first solution for this problem was just to SCP everything everywhere. We would take every single file that you needed to run your model and SCP each one from your local laptop to each of the remote instances. And this process was very brittle, and it involved a lot of communication with your local laptop. We found containerization technology to be a much more stable solution. For those of you, many data scientists are using containerization in production today, but for those of you who are unfamiliar with it, Docker is today's most popular containerization technology, but it's not the only one that's out there. To take advantage of containerization in this scenario, we would build an image on a local laptop. And an image is like a recipe that contains your code and your dependencies. Then we send the image to an image registry, and each remote machine only needs to communicate with the image registry to download an image and run a container. So what I like about this solution is that there's a lot less communication that needs to involve your laptop. It means you can shut your laptop and go home after you push the image to the registry. Not quite, though. So once you've got 6 remote instances set up to run your code, you need to actually kick off some sort of optimization job. So our first solution to this was to just open up a bunch of tmux windows and copy-paste commands into a lot of different tmux windows. I don't know if any of you have a similar architecture today, but I have seen several different places that have a lot of different tmux windows open on their terminals. And I see some smiles of recognition. And I'd love to talk to you about that if you are interested. But this process, it involves communicating with every single different machine. So if you want to run with parallelism of 6, that could be viable to communicate with each of 6 machines. But if you want to evaluate 100 models at a time, a process like this becomes a little bit more difficult to deal with. So we were really excited to try out Kubernetes. Kubernetes is container orchestration. We had already committed in our tool, in our machine learning infrastructure tool, to using containerization. And so Kubernetes was a natural choice because it just makes running containers a lot easier. For those of you who are unfamiliar with it, as I was at the beginning of the project, I would define Kubernetes as just an easier way of getting machines to talk to each other to run containers. There's also a Kubernetes master node that provides a unified API for talking to all of your machines. Instead of needing to talk to all 6 machines or all 100 machines individually, you can just communicate with the Kubernetes master API using one simple job specification file that says something like, run 6 copies of this container at the same time. And we run most of our infrastructure on Amazon. So we used Amazon EKS, which is their hosted Kubernetes service. Now in this machine learning infrastructure tool, you've gone from version 1, only being able to run models on your laptop. The next version involves SCPing everything everywhere and having a blinding number of tmux windows open on your terminal. And now this version, which involves you create one image on your local laptop, send it up to a registry, and then write one job spec file and submit it to the Kubernetes API. I would really recommend looking into these technologies for machine learning infrastructure tools because they simplify a lot of the process involved in getting models from a local environment to a cluster environment. And we found them to be great to work with and a great solution for some of our problems. But just using containerization and Kubernetes in machine learning infrastructure, while exciting, is not the end of the story. If you're like me, the code that you write does not run perfectly the first time you write it. So I, like many of our customers, hold my debugging tools very near and dear to my heart. When something goes wrong, I want to know what's going wrong and where I can find the information to debug what happened. And when things are going right, I just want to know that they're going okay. Just want to check in, say hi, what's up? Hope you're doing well. But what I've left you with from this last process is that you as a data scientist will still have to understand Kubernetes and Docker to be able to extract any information from this machine learning infrastructure tool. One of the ideas I believe in is that data scientists should be able to harness the power of containerization and Kubernetes in their machine learning infrastructure tools. But data scientists should not be required to understand containerization and Kubernetes. The user experience that's put on top of the machine learning infrastructure tools, whether it's a website, an API, a Python package, or a command line interface, is almost as important as the tool itself. This is the abstraction layer that allows the machine learning infrastructure tool to stop being just an infrastructure tool and become something that's feasible for use by a data science team. In our tool, we wrote 2 simple commands, logs and status, that wrap the other infrastructure APIs and the SIGOP API to show our users the information they wanted to see where they wanted to see it. So no more needing to understand what the infrastructure tools we were using were. We wrote the abstraction layer and packaged it up and tied a nice bow on top. And that's an important thing to look for and to build for if you are evaluating or building machine learning infrastructure tools. So I've talked about machine learning infrastructure, how when machine learning infrastructure is important to solve model building challenges that arise from things like hyperparameter optimization, define machine learning infrastructure as solving data science workflow problems using infrastructure and DevOps solutions. And I've shown you 3 examples of places in the data science workflow where containerization, Kubernetes, and command line, or really any user interfaces, can come into play and can help solve problems for teams. I know that command line interfaces aren't as exciting as containerization or Kubernetes, but again, I just want to emphasize the importance of your user experience for machine learning infrastructure. So my final thoughts are, like every company ever, we're hiring. So come talk to us. We've got a booth over in the sponsor area, and I would love to come talk to you there about machine learning infrastructure, hyperparameter optimization. You can connect with us at sigop.com. And me and my colleague, Mike McCourt, have written a paper about the orchestrate problem if you're interested in diving deeper on any of the technical challenges. Oops, just wanted to say thank you for your time. Yeah, and I can take questions at the booth. So the question was, have I used any tool like Kubeflow? So I have actually been a contributor to the KATIB project. SIGOP builds an API for hyperparameter optimization, and I have been advising on kind of standards for hyperparameter optimization APIs. So if anyone else is involved in any other projects building hyperparameter optimization APIs, I would love to talk to you about API naming and API endpoints as a kind of bid to help perhaps develop an industry standard. But Kubeflow can interoperate with SIGOPT, and the KATIB project offers some of the same functionality as the Orchestrate project geared for use in Kubeflow.